Welcome to the deep dive. Today, we are getting into something pretty technical. Maybe sounds a bit dry. It involves math and finance.
Always exciting stuff.
Right. But it's actually critical because it underpins basically all global climate and energy policy discussions. We're looking at a kind of, well, a spreadsheet battle.
A battle over numbers that decide if sustainable energy looks financially viable or not.
Exactly. Our mission today is to unpack the arguments in a specific scientific paper. It's defending a standard way these models work against some pretty sharp criticism.
And that paper is titled, Reply to: Bias in Energy System Models with Uniform Cost of Capital Assumption.
Quite a title. So it's all about digging into what happens when these big, clean energy future models meet the, let's say, messy reality of global finance.
That's a good way to put it. It's less about the energy itself and more about the money. The key concept here is how these energy system models figure out if building a power plant makes economic sense.
That's the LCOE thing, right? Levelized cost of electricity.
Precisely. And the most sensitive number, the one that can swing the calculation wildly, is the cost of borrowing money.
The cost of capital, or COSI.
Often called WACC, the weighted average cost of capital. It's basically the interest rate plus the risk involved in financing, say, a new solar farm or battery facility.
Okay, so how much it costs to get the money to build the thing. Makes sense.
And crucially, that WACC is heavily influenced by how stable a country is perceived to be, politically and financially. Sovereign risk.
Right. And this paper we're diving into, it's a reply to someone else who said, hey, wait a minute.
Yeah, the original commentary basically argued that using one single WACC number for the whole world, say 7% everywhere.
It was 7% in Germany and 7% in, I don't know, Sudan.
Exactly. They argued that this uniform rate creates a huge bias. It makes renewables look maybe too cheap in really risky places or too expensive in very stable ones.
Seems like a fair point on the surface. Risk isn't the same everywhere.
It does seem intuitive. But the authors of this study, the reply paper, they're defending that uniform approach.
Why?
Their main argument is that, look, for modeling this huge global energy shift out to 2050, using one number is actually the most practical and maybe even the least distorting option we currently have.
These distorting. How so?
And they also point out it lines up with what major international groups like the IEA and IRENA are already doing in their big reports.
Okay, let's unpack this. First off, why is this WACC number such a big deal? Like, if it's off by 1% or 2%, does it really matter that much?
Oh, absolutely. It matters hugely, especially, as you said, for renewables and storage. These are super capital-intensive technology.
Meaning most of the cost is building them up front, right? Not the fuel later.
Exactly. You pay off the loans over decades. So if your assumed interest rate, that WACC, is even slightly off, the final calculated cost of the electricity, the LCOE, can jump dramatically.
Give me an example. How dramatic?
Well, IRENA, that's the International Renewable Energy Agency, they've shown that just a 2% change in WACC, maybe going from 5% to 7%, that alone can push up the lifetime cost, the LCOE, of a solar project by like 30, maybe even 40%.
Oh, okay. That's massive. That changes whether something looks like a good investment or a terrible one.
Completely. It shifts the whole policy narrative. Suddenly, cheap renewables everywhere becomes, well, maybe too expensive for developing countries.
So that single number, that 7% or whatever they use, carries enormous weight. Which brings me back to, why stick with a uniform number if everyone knows risk varies?
Well, the authors of this study argue it's basically the industry standard for these kinds of global scenarios.
So everyone else is doing it?
Kind of, yeah. But their point is more about consistency. They say using the uniform assumption keeps the results comparable with the big reports policymakers actually read and use.
Which reports are we talking about?
They list them. The International Energy Agency, the IEA, often uses around 7%. IRENA, they mentioned, uses similar figures, maybe 7.5 to 10% sometimes.
And this study uses 7%.
This particular study used 7%, yes. And they add that other major research groups looking at, getting to 100% renewables globally, names like Jacobson, TESS, EIW, VTT. They also tend to use similar uniform WACC assumptions in their big models.
Okay, so it is common practice. But is it good practice? Isn't it just easier than trying to figure out the real cost everywhere? Maybe a bit lazy?
That's the critique,
Yeah.
essentially. But the authors of this study say the critics are missing the real problem,
Which is?
which is not about accurately capturing today's risk differences. The real nightmare is trying to predict what those risks will be in 2050 or 2100.
Forecasting.
Exactly. They argue there's just no scientifically robust, agreed-upon way to project the cost of capital for every single country decades into the future.
You'd have to predict political stability, economic growth, policy changes for almost 200 countries.
Right, 30, 50, 70 years out. It's fundamentally guesswork at that timescale.
Yeah.
They say the uniform WACC is basically acknowledging that forecasting limitation.
So it's a placeholder because the alternative predicting the future is even harder.
Pretty much. And they note this isn't just their problem. It affects other big climate models too, like the integrated assessment models, the IAMs.
Which are used for the big IPCC reports and things.
Correct. They often use uniform discount rates too, sometimes quite low ones, which really impacts how they see the cost of things like nuclear or carbon capture, which are also capital heavy.
Okay, so the authors say forecasting is the real issue. But the original commentary did suggest an alternative, right? Instead of the flat 7%.
They did. They proposed using country-specific numbers for 2050.
How did they calculate those?
Well, they tried to synthesize them. They took current real-world data, specifically average German costs for solar projects in the last 10 years, and combined that with current Moody's sovereign risk ratings for each country.
So basically taking today's risk level and just projecting it forward.
That's how the authors of the study interpret it, yes.
And what do they think of that approach?
They strongly disagree with it. They call it a questionable method.
Questionable.
Their core argument is that using today's risk ratings, especially for countries currently facing instability, and just assuming those high risks will still be there in 2050, well, that creates an even bigger distortion than using the uniform rate.
A bigger distortion. How?
They use history as an example. Look at South Korea, they say, or many countries in Eastern Europe after the Cold War. Their risk levels dropped dramatically over decades as they developed and stabilized.
Okay, so risk isn't fixed. It changes.
Right. And conversely, the countries that have the highest WACC today, the ones the commentary wanted to capture with specific numbers, are often places facing really serious problems. Civil unrest, conflict.
Like Sudan, which they mentioned.
Exactly. Sudan went through a terrible civil war, leading to sky-high perceived risk and cost of capital.
So the authors of this study say,
They say it's fundamentally strange, even illogical, to model a future where Sudan, for example, successfully builds out 100% renewable energy, which implies stability and investment, but simultaneously assume its cost of capital stays at today's crisis levels all the way to 2050.
I see. The financial assumption contradicts the scenario's success story.
Precisely. If the model assumes a successful transition, the financial input should reflect the expected stability that comes with that success, not lock in today's turmoil.
So using today's high risk for Sudan in a 2050 model actually makes less sense than using the neutral 7%.
That's their argument. They say applying that current wartime level risk to 2050 creates a greater distortion than the uniform approach. The uniform WACC becomes, in a way, an assumption about future stabilization being possible.
Okay, that's a subtle but important point. It's a modeling choice reflecting a desired outcome, not just current facts.
A pragmatic choice, given the lack of reliable forecasting tools for political risk decades out.
Right, so if the uniform WACC is the, let's say, least bad option for now, where do we go from here? How do we improve? And where does WACC matter most?
Well, as we've said, it matters most for technologies where capital cost is the main driver. So renewables and storage, definitely. Conventional fossil fuel plants are less sensitive.
So the accuracy becomes more important as we get closer to 2050 when renewables are supposed to dominate the system.
Exactly. That's when these WACC assumptions really bite. And the authors clarify their 7% uniform rate is really meant to represent the investment climate of 2050.
Not necessarily today's climate.
Right. They apply it backwards to earlier years simply because, again, they lack a better method to show how it might evolve year by year for every country.
Are there other factors models should include looking forward?
Yes. They mention one really important point, the role of international development banks.
Like the World Bank.
Exactly, or regional ones. They often finance big energy projects in developing countries at interest rates lower than what the local market or sovereign rating might suggest.
So that brings the actual cost of capital down in practice, regardless of the Moody's rating.
It can, significantly. And future models need to incorporate that mechanism better.
Okay. So wrapping this specific debate up, The authors rejected the commentary's alternative method, the one using 2017 data for 2050.
Yes, they found it more distorting.
But did they see any value in the commentary at all? Did it push the field forward?
Absolutely. They state they strongly appreciate the commentary for highlighting the fundamental need.
The need for what?
The need for a better, widely accepted way to actually project WACC from today out to 2050 and beyond. They agree that's the critical gap.
So the debate isn't really if WACC matters. It clearly does, massively. It's about how we estimate it for the future.
That's the core takeaway. The uncertainty around WACC is huge, but the real bottleneck is the methodology for forecasting it decades from now, especially considering political and economic shifts. Simply using today's numbers isn't the answer.
Right. So that brings us to the end of this deep dive. We've wrestled with the uniform cost of capital assumption in energy modeling.
Found that while it has acknowledged biases,
The proposed alternative, using current risk data projected forward, might actually create bigger, more philosophical problems in long-term scenarios.
yeah, the key takeaway, I think, for anyone looking at these long-range energy plans is that the biggest uncertainty might not be technological, but financial and political forecasting.
The ability to predict risk and the cost of money decades ahead, that's the methodological void,
Precisely.
which leaves us and you with a final thought to chew on. We know WACC hits renewables and storage costs the hardest. So if the financial inputs for these crucial technologies in all the major 2050 scenarios, even from big agencies, rely on what is essentially a placeholder number like 7%,
Because we currently lack the tools to reliably predict future risk country by country.
then how much certainty can we really place in the fine details of those scenarios? The models might be sophisticated, but that core assumption about future financial stability is still fundamentally an educated guess based on current limitations. Something to think about.
Definitely something to keep in mind when looking at those projections.
Okay, that concludes our look into Reply to Bias in Energy System Models with Uniform Cost of Capital Assumption. Thanks for joining us on the Deep Dive.
See you next time.